Welcome back everyone to the Minecraft modding tutorial. We're going to get back to working on the TileEntity, actually working on the TileEntity today. But before we do that, I'm going to go ahead and show something from Silent Gear. And I believe I said this before, but I'm kind of using the metal press from Silent Gear as a template for this. And we are going to be modifying a few things as we go. Okay, and unfortunately, it looks like that's not going to work today. Okay, so I'll pass on that for now, unfortunately, but I mean, it's a pretty simple concept. It's a machine that takes an ingot and turns it into a plate. And at first, we're just going to have it working for free, basically. It's not going to burn any fuel, it's not going to take any energy. We will make it use forge energy in the future. And something else that someone pointed out is that with the way the recipes are right now, there's actually no way to tell it how long the recipe should take to process, like you can with a furnace recipe, or how much energy it consumes, so we will add those in a bit later. And that's pretty simple, really. I mean, we've already got this serializer class here, which is taking care of reading the JSON. It's just going to be a couple more lines of code in here. And of course, the from network and to network, we have to account for that as well. But let's go ahead and get to the TileEntity. So for now, we're going to give it a constant work time. And let's say, just for right now, since we're testing it, let's say it takes 2 seconds. So there are 20 ticks in a second. So 40 ticks, or 2 times 20 is 2 seconds. Then later on, maybe we'll change this to 10 seconds, or something like that. Now we're going to include just one variable for now, and I typically call this progress. So this is basically a counter that increments as the TileEntity is doing its work. And by work, I mean processing the recipe. So now we're going to have one more thing in here, and I kind of hate these things in a way, but I understand roughly how they work. And this IntArray thing, this has a big issue that it's a vanilla issue, but vanilla never runs into it for reasons I will get into in just a second. So I've been calling these fields. I think it has something to do with what the methods used to be called in MCP. I honestly can't remember at this point. But we're just going to create an anonymous class that implements this IntArray interface. So this has 3 methods. I'm going to put the semicolon down there to get rid of the error. It's got a get, a set, and a get count. So the get has one parameter, which is the index. Set has an index and a value. So what we want to do with this is, this allows us to send some data over the network in a moderately convenient way. So basically what we have is we have an index that gets mapped to some variable, and then we can get and set that value, and this will be accessible through the container so that we can communicate between the server and the client. So typically what you have is a switch statement. You switch on the index, and we'll just start at 0, and we'll say 0 is our progress. So we return progress, and for the default, we're just going to return 0. Now for the set, similarly, we're going to switch on the index, and for case 0, that's our progress variable. So we're going to assign progress the value of value. And don't forget to break after each case. We're not breaking up here because there's a return statement, so putting a break there is actually invalid code. So just remember to include the breaks in set, because if you don't, then it's going to fall through to the next case, and you're going to be assigning a value to some other variable that you do not intend to. So remember the breaks. And there's no default case required for set because we're not returning a value. Okay, and for get count, we want to return how many different fields we have, which in this case is just one. Okay, so our constructor is good like it is. For the encode extra data method I have here, what I'm going to do is what that to-do comment said. I'm going to write the size of fields, so fields.getCount. And that reminds me, I said there was a problem with the IntArray field, and that is, even though it says they're integers, it actually encodes them as shorts. So if the value you need to pass is outside the range of what a 16-bit integer can store, you actually need to break that up into two different indexes and pass like the higher bits from one and the lower bits in the other. It's convoluted. We're going to need it for the Forge Energy implementation, and I'll cover it when we get to that. So now we've got this lovely tick method here, which comes from the iTickable TileEntity interface. And this is the method that gets called every tick, so that's where we're going to do the work of processing a recipe and all that. I'm going to go ahead and make a couple more methods though. So this first one is going to get a recipe. And basically it's just going to look at the inventory and tell what recipe we need to process, or it will return null if there is no recipe. So we're going to go ahead and check if world is null, because sometimes it can be. Got to figure out what that's called. Level. Okay, it's called level. In MCP mappings, that is world. So we're going to check if the level is null, which shouldn't be the case in most cases. And now we got to figure out how to get the item from the inventory. I'm learning the official mappings along with everyone else. Get item, maybe? Yeah, it's got to be get item. So if the item in slot 0 is empty, so basically we're checking if the level is null for some reason, or if our input slot is empty, then we're just going to return null. If not, we need to actually check what the recipe might be. So we're going to say this.level.getRecipeManager .getRecipe, that must be getRecipe4. So we need a recipe type, modRecipes.types.pressing. Do we need to .get on that? No, we don't. Okay, the iInventory is this, and the world is this.level. And what is your problem? Okay, that's an optional. Right. So on the end of this, we also need to say or else null. So this method gets an optional, and that optional could either contain a value or not. If it does, then we'll be returning whatever that value is, or if it's not, we return null. Okay, and I'm going to go ahead and write one more method here to kind of help out with the recipes. We're going to call this getWorkOutput. And of course, all the, like, for getRecipe and getWorkOutput, these methods are not strictly necessary. I'm just including them as a convenience to make the code more readable. So we're going to say if our recipe is not null, then we're going to return recipe dot. Learning the mappings along with everyone else. Is it a symbol? I guess it's a symbol. Let me check that. Yeah, that's got to be it. Okay, and if the recipe is for some reason null, we're going to return itemStack.empty. Remember, you almost never work with nulls with item stacks. If you want to represent a stack that doesn't exist technically, you use empty. Okay, now I'm going to go ahead and write a few more methods. You're free to call these whatever you like. I like to call them do work, stop work, and finish work. So for do work, we're going to pass in a recipe object, and this is non-null. And I'm going to go ahead and just assert that level is not null. Because at this point in the code, it should be. And we'll be checking that here in the tick method later on. So there's really no reason to check it again. Okay, so we're going to get a couple item stacks here. So the item in slot 1, that's going to be the current output. And the output of our recipe is get work output. So first, if the current output, what's in the output slot, is not empty, we're going to go ahead and figure out how many more of the item we should have, assuming it matches. So we're going to add the counts of current and output together. Okay, and in the code I'm referencing, I'm actually using a silent lib utility method, so inventory helper. I can't actually remember what you would normally use. Is same, maybe? Item stack.isSame. Okay, I think we actually want matches. So if current and output are matching, if they're the same item, same NBT, all that. Sorry, if they are not matching, or if the new count would exceed the item's maximum stack size, then in that case we want to stop working and return immediately. Next, we want to say check our progress. If it's less than our current work time, then we're going to go ahead and add 1 to the progress counter. Then we're going to say if the progress is greater than or equal to work time. In theory, it should never be greater than, but it's good to check. And we're also going to check if the level is not remote or is client-side. And in this case, we're going to finish work. And we're going to pass that recipe and the current output. Okay, so let's go ahead and create the stop work method. And for now, all we need to do in this case is just set progress to 0. In the future, we may change this block so that it has a different block state for when it's working, and in this case, we will set it to its inactive state in this method as well. All right, let's create finish work. So we're going to get the work output again, And why exactly am I passing current into this? Now let's go ahead and pass in our output as well. I'm not sure why the silent gear code is like that exactly. Must have been from using the refactoring feature. Just a little quirk of how the code turned out. Okay, so if the current stack is not empty, then we're going to make it grow. We're going to increase its size. Otherwise, I believe it would be set item. So we're going to set item slot 1 to output. And we're also going to set a progress to 0. And got to figure out what this next method is called. Remove item, maybe? Yes, I believe it is going to be remove item. So we're going to give it the index and the amount to remove, which is just going to be 1. So basically just shrinking the stack in the input slot by 1. And that's all we need to do for this method. Now finally, let's go back to the tick method. We're going to say if level is null, or level.is client side, we're just going to return and not do anything. So at this point, we're on the server for sure, and we've got a level object or world object. So we're going to get the recipe. If the recipe is not null, we're going to do the work that the recipe calls for. Otherwise, we're going to stop working. So I just realized I've kind of got a redundant client-side check in here, don't I? So I should be able to just remove that, because we're never doing anything on the client side. Okay, so now we've got a bunch of other methods that we need to override. So we've got get slots for face, and I'm just going to return an array of 0 and 1. So those are our slot indexes. 0 is the input slot, and 1 is the output slot. We're just going to say that either of those can be interacted with from any side of the block. Can place item through face. That must be what they called can insert item. So let me go and fix these parameter names. So that'd be the index. That's a stack. That's a direction. And in this case, I'm just going to say, well, I got to figure out what it's called first. Can place item, maybe? That definitely looks right. Okay, so can place item, index, stack. For can take item through face, we're just going to say if the index is 1, you can do that, and that's the output slot. This is our index, stack, and direction. So any face, you can take anything out of slot 1. For get default name, we're going to return a translation text component of container.tutorial, that's our mod ID, .metalpress. We'll add that to our lang file later, or I may forget about it. That's more likely. Okay, for create menu, we're going to call that ID. That can be player inventory. And we're just going to return a new metal press container. Do we not have the container? No, we have not written the container yet. So we will have to come back to that. We're going to pass it ID, player inventory, this, and this.fields. Okay, get container size, that must be get inventory size, so that's 2, it has 2 slots. For is empty, we are, in this case, I suppose it'd be best to just say get item 0 that is empty and get item 1 that is empty. For get item, that's the index. And right, we have to actually make the space for the inventory ourselves here. So go ahead and rename some of these parameters. That must be index. That's the index. Stack. Player. So again, I'm used to using some classes from Silent Lib, so I've got this base TileEntity class that already has some basic handler stuff in it, so we're going to have to replicate that. So let's go ahead and do that right here. We're going to make a non-null list of item stack. We'll just call that items. And we're going to have a private final lazy optional of something extends item handler. And we've actually got an array of those. We'll just call that handlers. So I need to initialize that in the constructor. We're going to say this.handlers is assigned a value of cited inventory wrapper dot create. And we're going to pass it this. So it looks like I'm using up, down, and north. That doesn't even need to be an array, does it? Why is that appearing as... Oh, it's probably because it's decompiled code that I'm looking at. So yeah, remove explicit array creation. That's not necessary. And we're going to assign items as a non-null list with size 2 and fill it with empty item stacks. So I believe this list could be final as well in this case. Okay, so back to get item. That's going to be items.getIndex. Remove item. We are going to call item stack helper dot remove item. Pass it items, the index, and the count. Or, well, I called it amount, didn't I? I'll call it count. For remove item, no update. I'm guessing that's what they called remove stack from slot in MCP. So again, we're going to defer to item stack helper. And I need to figure out which of its methods to call. Should be the second one, take item. So pass it items and the index. Set item, we're going to call items.set index stack. And I believe that's all we need there. For still valid, that was previously called is usable by player. We're going to return world, or level is not equal to null. Getting used to world being called level is going to be so hard. And this .level dot get tile entity, get block entity. At this .world position. is equal to this. And we're also going to check if the player's distance to these coordinates, square distance to the coordinates, is less than 64. That's what furnaces do, so that's what I'm going to do in this case. And I think we also need to add a half in here just to check distance to the center of the block. Okay, what did I mess up here? Comma instead of a plus. Okay. Let's get rid of those parameter hints because they're really not helping in this case. Okay, and finally clear contents. That's items dot clear. Okay, now there's even more methods we need to override, and I'm probably going to have to figure out what they're called. Okay, so the first one I want is going to be load. Let's rename the parameters. And we do want to call super.load. Let that do its thing. For the items, we can call non-null list dot. So that's why it wasn't final. Okay. I should trust my own code a little bit more than that. With size 2 empty item stacks. And we're going to call item stack helper dot load all items. Pass it to compounded NVT. And our items. Now we've got a save method. So calling super.save is fine. Then we need to call item stack helper.save all items. Tags this.items. And return the tags. Now we got another method to override. Just got to figure out what that's called. Okay, so we've got get update packet. So we're going to make a compounded NVT. And we're going to get that from the get update tag method, which we're also going to override in a minute. I'm going to save all of our items to it. And return a new instance of this packet. I believe the second parameter doesn't actually matter what you put in. Okay, and I just realized I forgot something kind of important from these save and load methods. We also need to take care of the progress variable. So let's just go ahead and store that as a full integer. Doesn't really matter. Just call it progress. Doesn't matter what you call it as long as it's consistent. And in save, we want to put that value using the same name as we used in load. Okay. Now for get update tag. This is pretty similar, except we don't actually need to pass the items in most cases. I believe this is used for just syncing information about the TileEntity to the client. But only in the context of the block being in the world, not with a menu open. So in this case, I believe all we really need to worry about is that progress value. If that, actually. We may not even need that there, but I'll go ahead and write it anyway. Okay, so now there is this get capability method. We're wanting the one that has 2 parameters. So this is actually a method from Forge. And we're going to return an item handler capability here for mods to interact with. So I'm guessing removed is called remove in this case. Yeah, that's got to be it. So if not this.remove, and side is not equal to null, and the capability is equal to capability item handler dot item handler capability. It's very redundant, I know. So in this case, the tile entity still exists. We've been given a specific side, and we're looking for an item handler capability. So we're going to say if the side is up, so the top of the block, we're going to return this.handlers index0.cast. Otherwise, if the side is down, we're going to return handlers sub1.cast. And otherwise, we're going to return handler sub2.cast. Okay, and back at the end of the top level if statement, we got another else, and we're just going to say return super.getCapability because it's something completely unrelated to anything we know about. Okay, finally, I believe the method I want is setRemoved. So we can leave this super call in there. And we want to iterate over our handlers. And we want to call handler dot... Okay, here's what I'm looking at with this decompiled code here. It's like, what the heck? That is clearly not the code that I have written. Okay, I'm gonna go check this really quickly just to make sure that I'm not making a mistake. Okay, should just be handler.invalidate. Okay, I don't know why I didn't see that before, but yeah, that's all there is to it. Okay, and I'm not sure why this is complaining about nullability problems. I think that should actually be marked nullable. Yeah, okay. No? Alright. I don't know what it's complaining about here. I guess just check the code on GitHub again. Let's see. Git capability. Yeah, it's supposed to be marked as nullable. I don't know why it's doing that. Okay, so I believe that's all the TileEntity code, but unfortunately this is still not in a state where we can test it. So let's see, been recording for 46 minutes on the dot, so I'll go ahead and cut this one here so I can get to editing it and hopefully get it up soon. Next time we'll try to do the container and the screen, and then maybe it'll be in a testable state by then. So thank you for watching, I hope this was helpful, and I'll see you next time.